All right, so again, what I want to start with is your homework. Did you guys have any homework questions for me? This is, yesterday we talked about complex numbers. Anything? No, we did not. Did we do distributive property yesterday? What is today? Today's 38. We did complex numbers yesterday. It's a big blur for me. All right. So today what we're doing is factoring. Factoring. So pull up your notes. I want to remember what it means to factor. So think back when you were making a factor tree back in elementary school. Sure you can. So 20 is 2 times 2 times 5, right? Those are factors of 20. Those are numbers that divide 20 evenly, okay? These are the prime factors of 20. If I want to list all the factors of 24 that go into it evenly, I would start this way. Well, I know 1 goes in evenly. 1 and 24 multiply to 24. And those can be positive or negative. What's the next number that goes into 24 evenly? 2 and 12, plus or minus 2, plus or minus 12. What's the next number that goes into 24 evenly? 3. Or minus 3, plus or minus 8. What's the next number that goes into 24 evenly? 4. Those are all the factors of 24. So when we factor an expression, what we do is we take a sum and we write it as a product. That's the idea. Okay. So what is a factor? It is a value that divides evenly into a number. Number that divides another evenly. Okay. So as I look at these boxes, each of these expressions that are below here are considered quadratic expressions. I want you to look at them and decide what you think. What do you think is the same about all of them? What do you think we mean by saying something's a quadratic expression? Tell your neighbors. What's the same about it? Okay, what do we think, you guys? What do you think it is about these that causes us to call them a quadratic expression? Ideas? Yeah. Yeah, if it's an expression that has x squared in it, it's quadratic. So all of these have an x squared term. Okay, that causes it to be quadratic. Yeah.
For quadratic equations, you can have like different exponents too, rather than just 2.
For a quadratic equation, no. A cubic, we're going to look at later this year, but quadratic, the highest exponent you have is 2. Okay. So what is a quadratic expression? Well, it looks like this. Where A, B, and C are real numbers. And A is not equal to 0. So that's a fancy way of saying that I look at this polynomial there, it's a bunch of terms added together. In the term with the highest exponent is a 2. And I have to have it. So if the highest exponent I have in there is a 2, it's a quadratic expression. And by the way, if the highest exponent I have in there is a 1, it's a linear expression, which is why before when we were solving linear equations, I meant I didn't have any variables squared or higher. Okay. Now, based on the definition of the word factor, determine if the following expressions are pairs of the quadratic expression. Show your work. So I'm going to start you with this one. If 2x and 3x minus 4 are factors, that means that when I multiply them together, I should get 6x squared minus 8x, right? They should multiply to that. So I'm going to multiply them and check. Distribute the 2x, that's 6x squared minus 8x. These match. So yes, 2x and 3x minus 4 are factors. Okay. I want you to do just this one down here. Okay. Hey, Connor, can you fix your mask for me, please? It's okay. Okay, are we done yet? Raise your hand if you're done. Beautiful. So yes, it is. They multiply to 9 minus 4x squared. So these are factors. Okay, now our goal today, remember we've done the distributive property where we multiply these guys together and we get here. Our goal today is to start at the other end and go backwards to where we have it. We write this difference as a product. Okay. So the first method and the first thing that you always do when you are factoring anything is you look for a greatest common factor. So what we're doing here is the reverse of the distributive property. Remember when you use the distributive property, you multiply. If I want to do the reverse of the distributive property, what's the reverse of multiplying? Yeah. So now I'm going to look at 4x squared minus 12x. And I'm looking for the highest number that goes into 4 and also 12. What is it? 4. Now, look at the variables. I have an x squared here and an x. The GCF is the variable to the lowest exponent. So this guy comes out. What's inside gets divided by 4x. So this would be just x. 4x squared divided by 4x is x. 12x divided by 4x is 3. And it's a negative 3. Do you see how this is the reverse of the distributive property? Okay, thumbs up, thumbs down, thumbs sideways. Okay, I know you guys have all taken out GCF before, right? Okay, good. What about what? When that's next time, we'll tap at some point. Got to mix it up a little bit. We like tapping, huh? Okay, all right, now. I want to look at. We're not doing that. I want to show you something else. So skip these two. And I'm going to write this. Okay. Now, I made this up. I'd like to factor it. Now, the thing we're going to do before anything else is we are going to rearrange this from highest to lowest exponent. So we're going to move the 45x squared to the front and the 35x to the back. Do that every time. Highest exponent first to lowest exponent last. The next thing that you need to do is factor out the GCF. If my leading coefficient is negative like this, meaning the number that's in front of the squared term is negative, we're going to factor out a negative value. So what's the highest number that divides 45 and 35 evenly? 5. So again, we're going to factor out a negative 5 and an x. If the leading coefficient's negative, we're going to factor out a negative. Okay. Now, inside of here is what I get when I take each of these and divide by negative 5x. So this is 9x squared minus 7. 9x minus 7. There we go. Yeah, that's what I meant. Okay, how are we feeling about that? One figure to 5. Okay, great. All right, I want you to do these 3. Remember to reorder it if necessary. When you're done, put your pencils or stylus down so that I know compare answers with your neighbors.
No, I won't. No.
Okay, I'm hearing a lot of talking, so that probably means that you're done. So we did these 3. Okay. Do you guys have questions on these? Yeah, Rylan.
For the second, like the middle row.
Yeah.
that one, I said minus.
Yeah. Well, no. Yeah, -1. Thank you. Anything else? Okay. So that's factoring out the GCF. The next thing I want you guys to do is multiply these. Multiply these binomials, all three of them. Multiply the binomials. You should be noticing something. What do you notice? The middle term cancels out, right? Kind of nice. So I end up with no middle term in each of these, no x term. So let's think about this. What do all the factor pairs in the previous examples have in common? What would you say about this? Well, factor pairs. What would you say? Look at these numbers. Yeah, they have the same numbers, right? There's only one difference. What's different about them? The sign in between. So they are all in this form. I have the same number in each of those binomials. The only difference is the sign between them, right? Okay. So when you multiply them, the binomials and when I multiply them, the result gives me this. The middle term cancels out. And those values there are perfect squares. So look at, that's a perfect square, so is that. Perfect squares, perfect squares. This is the difference of squares. It is the difference of squares. Okay. All right. So far, what we know about factoring are these three things. You know that the first thing you need to do is reorder your terms from highest to lowest exponent. Reorder your terms from highest to lowest exponent. Connor, picture math, please. The next thing we need to do is factor out greatest common factor. And then we need to check to see if it's the difference of squares. Can I help you guys? Do you have a question?
Sorry, can you show off again?
Yep, absolutely. Do you have it?
Yeah.
You good? Rylan, don't get me in the picture. I won't like how I look. All right. Do we have any questions? Now we can tap. 5, 6, 7, 8. That's pretty good. Okay. So now,
Wait, can we go back down to our?
Tommy,
What was GCP stand for?
GCF, greatest common factor. So you have difference of perfect squares, perfect square minus perfect square. Look at 4x squared is perfect square, 9 is perfect square. Difference of squares. Subtraction. Okay, so we're gonna do some like this because then we know how it factors. So hold that thought. I'll show you what I mean. Actually, let's do this. If I gave you this problem, remember, we're working from factoring is the reverse of multiplying, okay? So if I had 49x squared minus 64, this is a perfect square and so is this, right? Well, that means I want to know what A is and what B is. A would be 7x and B would be 8. So this would factor as 7x plus 8 times 7x minus 8.
But how come it's X? Oh, I get that.
Okay. Now, let's look at some problems. I'm going to do this one with you first. No, I'm not. Hold on, I want to do. Actually, I'm going to do this one with you first. Okay, now, the first thing I have to do is reorder it from highest exponent to lowest exponent. It's already ordered the appropriate way, so there's nothing to do. The next thing I need to do is factor out a GCF if there is one. And if my leading coefficient's negative, the GCF I factor out must be negative. So what is the GCF here? -3. So the -3 factors out, and I have x squared minus 9. Now I am going to keep factoring because this is now the difference of squares. In this case, my A is x and my B is 3. So I can further factor this as x plus 3, x minus 3. And this is my fully factored answer.
How do you know how to do that? Like, what's the problem with leaving it in its original, like X squared minus 9?
Because it's not fully factored, and later on, when you want to solve a quadratic equation, you're going to want it to be factored. Okay? All right, now I want you to do these 3 problems here. This guy, and that guy. Do those 3 problems. When you're done, hear your answers with your neighbors. No, I can't look at it.
Yeah, it's like, well,
Okay. These are the answers that you should have gotten. Okay. Any questions for me? Yeah, Rama.
So for like, the 8x minus 18x squared, going to be 15x minus 60x squared, how come you didn't factor more, like the perfect square ones?
Because this is just 4x,
Oh, okay.
not 4x squared. If it was 4x squared, I would, but in this case, they're not.
So it's only if it's squared?
Correct.
Okay.
Jane?
Doesn't matter the order of the parentheses, like, if you did.
No, if you do x plus 3 before x minus 3, that's fine, because
like, for the third column, would it be?
this one,
Yeah, can you do negative 2x and then parentheses negative 4 slash 7?
well, technically that's correct. Remember, we're listing things in order of decreasing exponents.
Oh,
So I want the 9x first, okay? All right. I want you to just do a few of these. I want you to multiply these guys out. These three. Multiply them out and then summarize. Here, I'll help you with the first one. So multiply out the 3x. We're going to distribute the 3x. This is 3x squared minus 6x minus 4x plus 8. Then combine like terms. So I'm going to summarize some information. The first thing that I'm asked is what's the product of the first terms from each factor? Well, I got the first terms here. The product is 3x squared, right? The product of the last terms from each factor is minus 4 times minus 2, that's 8. Product of the outer terms, 3x times negative 2 is minus 6x. And then the product of the middle terms, negative 4 times x is negative 4x. Okay, do the next two, and then we're going to summarize. This is what you should have gotten for the next two. So, any questions on these next two problems? Here and here. Raise your hand if you got them right. What's your question?
The middle term?
For this one?
Would that be, oh, yeah.
It's minus 8 plus 6.
Yeah, I was looking for one.
Okay. So we're going to summarize this a little bit. 3 statements that relate the final answer in each example of the above to the 4 quantities that you were asked to identify. Okay. The first term is the product of the, what do we call it here? Product of the first terms of each factor. Hold on. The product I know I can write it the other way too. Hold on. Okay, the first term is the product of the first terms of the factors. Okay, so let's go look above here a little bit. Notice this guy matches that guy. This guy matches this guy. This guy matches this guy, right? So I multiply those first two terms of my binomials. It matches the first term of my expression, okay? The next thing that we should notice is when I multiply the last terms of my factors, it matches the last term of my polynomial. Okay. So the last term is the product of the last terms of the factors. And the very last thing we should notice is this. Look at. If I add the products of my inners and outers, it matches the middle term. Right? Negative 6x plus negative 4x, negative 10x. 6x minus 8x, negative 2x. 8x plus 8, negative 8x. Hold on, I can't see here. Yeah, 8x plus x, 9x. Okay. So the sum of the products, thank you, of the inners and the outers is equal to the middle term. Okay. Now I'm going to show you how I learned to factor way back in high school. And it is definitely not the most efficient way, but it is the way that this is driving us to go. Okay. It is a way of understanding how it works, but it's not a way of efficiency. Okay. Now, once everyone has this written down, I'll go on to the next page. I don't want to do it until you guys are ready. While you're working on that, I'm going to make up a problem. Let's see. Okay. So when we factor this, we're looking for two binomials that will multiply to that. So it's going to be the two binomials. I need two numbers, two values that multiply to 3x squared. So luckily for us, that's my only option is 3x and x. Okay. What goes here and here has to multiply by 4 to 4, but my middle term has to be -8. So whatever I put here is going to get multiplied by 3. So it's a little bit of a trial and error process. That's how I learned anyway. Okay. And trust me, there's a better way, which I'll show you in a moment. Okay. So if I wanted numbers that multiply to 4, I would have 1 and 4 or 2 and 2. Okay. Let's put the 2 and 2 here and see what happens. Whatever I put here and here has to multiply to a positive number, but add to a negative, which means that both of these have to be negative. But now I got to check to see that it creates that middle term that I want. -6x minus 2x. Oh gee, I got it the first try. Negative 6x minus 2x is negative 8x. So that is how it's factored. Let's pretend for a minute, though, I picked the wrong choice. 1 and 4. Clearly, my first terms multiply to 3x squared, right? And my last terms multiply to positive 4. But when I check my middle term, I have minus x minus 12x, which is minus 13x, and that does not match my middle term. You got to keep going until you find the case where it works, or you determine that you cannot factor it. Okay? Now, this is how I do it in reality. Okay? Let us first multiply our 3 and our 4. This is called the AC method. The AC method. I want to go to a different page. Hold on. Let's move this. Okay, AC bottoms up method. So I multiply my 3 and my 4, multiply the leading coefficient and the constant, A times C. So in this case, it would be 12, the 3 times the 4, okay? Now, I need to think of numbers that multiply to positive 12, but add to negative 8. So we're going to find numbers that multiply to AC and sum to the middle term. So what multiplies to 12 but adds to negative 8? Negative 2 and negative 6. The next thing I'm going to do is I am going to divide each of those values by the leading coefficient. And simplify. So take each of these and divide by my leading coefficient. And I'm going to simplify that fraction. This does not simplify, but this other one does. Now, I want you to look at these for a minute. Remember, we just factored this up here by trial and error. You see how it factors? And do you notice anything about the numbers? And think about bottoms up. 3x minus 2 times x minus 2. Bottoms up. These will be the coefficients of my factored form. So it factors like this. 3x minus 2 times x minus 2, 1x minus 2. All right, so how are we doing? Have you guys ever seen that before? Oh, much more efficient. If I'm really honest with myself, that's how I do it. Yeah, and actually I'll do the next problem that I have written on here and we'll do it again, okay? So let me write this down. The result gives you the coefficients of the factors. Okay, so now let's look at the problem I had intended to do with this guy. So our first step is we're going to multiply our A and our C. Our A is 4, our C is our 5, so multiply those, 20. I need numbers that multiply to 20. I gotta change my color here. Ugh, ugly, okay. I need numbers that multiply to 20, but add to 12. What are those? 2 and 10. Two and 10. Okay, so now I've got it. I find the numbers that multiply to the AC and sum to the middle term. Now I'm going to divide each of these by the leading coefficient, which is 4. And I'm going to simplify the fraction if I can. This simplifies to 1/2. This simplifies to 5/2. Right? These numbers are the coefficients of my factored form from the bottom up. This is 2x plus 1 and 2x plus 5. Now let's just check it to verify. 2x times 2x is 4x squared. Yep, that's my first term. Let's check my last term. 1 times 5 gives me the 5. Let's check the middle term. 2x plus 10x. Aha, 12x. Done. Okay. Really, really nice. It's a little bit of magic. That's the problem. The trial and error, you really understand how that's working, right? But the bottoms up works every time and it's very efficient. Now, I want you to do these 4 problems. And I want you to remember, first, you're going to reorder it. Highest exponent to lowest exponent. Then you're going to look for a GCF, and then you're going to continue to factor. 1, 2, 3, 4. Those 4 problems. What time are we out? 2 minutes? We'll try these, and then we're going to pick up here tomorrow. I got to show you something else. Okay. You'll still be able to do your homework though. We're factoring for 2 days. Now, factoring is incredibly important. There comes a certain point in math, if you cannot factor, you fail from then on. You must be able to factor. You just do. Okay. Do as many as you can. I'm going to show you the answers in a moment. Okay, I'm going to pull the answers up here so you can at least see what they are on the ones that you finished. Boy, hard to see, isn't it? Bye, have a nice day. I'll see you guys tomorrow. We'll factor more tomorrow. Bye.
I wasn't here yesterday, and should I like come?